Okay, so I've just erased everything that we've done so far up to begin play. So essentially all that is in here is our begin play method and our constructor and the default log setting up and the commented out message, as well as the log implementation, definition rather. Okay, so before we get into functions and multiple returns, we need to understand a little bit about pointers, okay? And I'm actually going to utilize a very good article on pointers, and it is written by Paul DeLorenzo. I don't know if I'm pronouncing his name right, but he is he's a PhD student, or rather he's a PhD, and he wrote an article on pointers. And so I'm just gonna utilize his thing, and I will type out his I'll type out the site in which I'm using right there, and I'll include this link in the video description for anybody who would like to go read it. If my video tutorial doesn't actually make sense, just go there and read up on pointers and you will understand them. He did a very good job on writing this article. It's absolutely amazing. So let's get started. So he says pointers are very difficult and troublesome area for most C++ programmers, beginners and intermediates alike. Most questions pop up about their use and why we even need them. I hope this website helps answer these questions for you and demystify the C++ pointer. To understand pointers, we have to understand how variables are stored. Variables are stored in memory cells inside the computer's memory. The computer's memory is made up of consecutive memory cells a byte long with each a unique address. But we're not going to think in those terms. We're going to believe that the computer is made up of a bunch of houses on one very long street. Thus, each house is a memory cell. Now, there must be a way for us to find this house. Well, in each house, someone lives there. This person, of course, has a name, and this will be our variable identifier. For example, Paul. He is a variable. Okay? We know this so far. This will put Paul in a vacant house of size int 8, which in our case, since we're not using the standard STL, which would be just basic int, we are utilizing UE4's int of 8 bits. So let's save that. And this will put Paul in a vacant house of size int and somewhere along the street. Actually, you know what I'll do is I'll do it 32 because that is the default size of int in C++ standard library. So we'll just do it this way so that we're consistent with the article. So it says we do not decide where Paul will live. This is done by the operating system and the compiler at runtime. In a later section, we will discuss how Paul will tell us where his house is. Currently, Paul does not have anything stored in his house, but we know it wouldn't be fun to not store anything. So each house can, of course, store a value. So to continue, what we'll do is we'll just initialize Paul to 25 or 25. Okay, so this stores 25 into Paul's house. One last thing before we move on to other topics is let us remember that Paul's house is our unique number in memory. In addition, if Paul's house was numbered 1, 2, 3, 4, we know that his house is between 1, 2, 3, 3 and 1, 2, 3, 5. This is a very important concept for later on. So let's move on to where do you live. It says, following along with our simile, when we declare a variable, a person is put into a house so we can access what is stored there. But what if we wanted to know where the person lives? This is done by the preceding variable identifier with an ampersand sign, which means the address of. For example, let's grab ourselves another variable. We'll call it Melissa, and right now we'll give ourselves a few more variables. Don't worry about them for now, but we'll use them in a second. So if Paul is equal to 25, right, we can set Melissa, M-E-L-L-I. It's my sister's name. I should know how to spell it. It's not two L's. It's two S's. So if we use the address of Paul, what this is saying is we're storing the address of Paul into Melissa. And we're storing the address of Paul into Melissa. Now let's suppose Paul's address is 1500. So we'll do now if we said Tom equals Paul, this would say that Tom was equal to 25. These are two different statements. You're not storing the value at all. You're storing the address. You are referencing Paul's address and storing it inside of Melissa. So let's look at this little helpful flash diagram. So we have Paul and Melissa and Tom. Paul equals 21, so Paul gets 21. Tom equals Paul, so Tom is now equal to 21. And Melissa equals the address of Paul. So Melissa now equals 1500 address. The variable Melissa is what we call a pointer. We've not yet gotten into how to declare a pointer, but it has certain qualities in which we will discuss. Okay, so in our previous example, we set up where Paul is located at address. Well, we didn't actually define him to be at address 1500. We just stored a value of 20. I'll make it consistent with the article. 21, and his address is 1500. So now what if we wanted to know what the value stored at the house in which Melissa was pointing at? To do this, we would use the reference operator. This is a asterisk, so the little star. And this could be thought of saying the value pointed by. So, for example, if I were to type in Dave equals the value pointed by Melissa, this will store 21 into Dave's house. So Dave equals 21. Melissa equals address 1500. And Tom equals 21. Okay. To follow our simile, Dave will ask Melissa what value she's storing. She will say 1500. Dave will then go to address 1500 and ask the person living there what is stored in their house. That person, we know who is Paul, will say 21. So Dave will know to store 21 in his house. So let's look at an interactive example of how this would look like. So we have Paul at address 1500. We give Paul the value of 21. We say Melissa equals the address of Paul. So she gets the address of Paul. Now Dave asks Melissa, what is the value you're pointing to? And then that means Dave will get the value of 21 because Melissa is pointing to address 1500, which is storing the value of 21. Okay. So from this example, if we printed out the value of Dave, it would say 21, right? We could also type something like this, which would say the value pointed by Melissa equals 30. This would read the value pointed by Melissa equals 30. So Paul would now equal 30, but Dave will not equal 30 since he does not get updated. He stores what he originally stored and does not change. Until now, I've glossed over the detail on how Melissa is created, and the next section explains how to declare a pointer of a certain type. So let's go to that. And it says, don't point, it's rude. Okay, so we have learned about the address of operator. That's the ampersand. And the reference point operator, which is the asterisk. But we haven't learned how to declare a pointer and use these operators on. Well, so let's get rid of all this. Or well, okay, let's not get rid of it, but let's go below this. And you know what, I'm actually going to put this in a comment, a multi-line comment. Okay. So this is how you initialize a pointer. So you would say the variable type, and then you would say Melissa, but instead of this time saying just that, what you would do is you would say that. You would give it an asterisk. And this tells the compiler Melissa is going to be a pointer. And what this is saying, it will move Melissa into a house whose sole purpose is to store the address of someone else in quote-unquote computer town. Basically, she is a pointer. There are a few rules I should explain before we go on and learn how to tell her where to point. If we have a code of line like this, let's just use a different name than Paul, but we'll use Rob. If we had a code of line like this, it does not create two pointers. It creates a pointer named Melissa and a regular integer 32 named Rob. If we declare two pointers of the same type, we would have to say that. Another thing is size. A pointer must know how big the house it is pointing to. So if Paul is an int, or rather Rob is an integer, only an int pointer can point to it. So if Paul was a float, or rather Rob was a float, then only a float pointer can point to it, and so on. So if we had these like this, you could not, these variables would not be interchangeable. A float pointer can only point to a float value, and so on. And you have to remember that data types are separate. They're not the same. So let's go on to, I am pointing here where are you pointing? Now that we know how to make a pointer and we have initialized it, we have actually done this before. We've used the ampersand symbol to get the address of the variable we want to point to and store that in a variable. So that was essentially this part right here. So we will move Paul into his house, so that's this bit, and we'll store 21 in it, and then we declare that Miss Melissa will be a person that only points to the houses of size int. So that was this bit. We will tell Melissa to point to Paul's house. So what I'll do is I'll actually show you what the code actually says on his side. We will create two people who point to Melissa and Dave. Melissa will store the value of the address Paul, as seen on line 3. But then Dave will also store the value of Paul because he gets it from Melissa. So now that we have two people pointing to the same house, isn't that cool? So what we'll do now is, since we've gone over kind of how these work and everything, what we're going to do is we're actually going to set up a little example. So I'm going to type out a bit of stuff, and I'm going to go on to the next page. Now, what I want to ask you guys is, before you actually run this, think about what the value of Rob will be and what the value of Bob will be. So if you can figure out what the value of Rob and Bob will be through this example, you'll pretty much understand pointers. If you understand this without running it, you should be good. But if you don't, run it and see how close you were. So what we'll do is we'll run this and we'll check out what it says. So we have my actor BP in here already, so if I press play, hopefully it doesn't crash. Great. Now we can scroll down here, and before I scroll down anymore, I want you guys guess in your head what Bob and Rob will be their values. Now I already know what their values will be. Okay, so I want you to guess what the value of Bob and Rob will be when this gets printed out. If you're thinking that Rob and Bob will be 5 and 10, you're wrong. If you thought that Rob equals 10 and Bob equals 20, you are absolutely right. So what is this saying? How did we get Rob equal 10 and Bob equal 20? Well, we initialized the variables to 5 and 10. So right now Rob is 5 and Bob is 10. So we said Rob's pointer equals the address of Rob, and we told Bob's pointer that you're going to equal the address of Bob. So we told Rob's pointer that we're telling essentially Rob, because it is the ampersand operator here, we're telling Rob's pointer that since we're telling Rob's pointer to point to the address of Rob, when we say this line, we're not telling Rob's pointer that you are now equal to 10 because it's a pointer. It's only going to point to address. So we told Rob that he now equals 10. So when we tell Rob's pointer to equal Bob's pointer, we're essentially saying Rob's pointer is now equal to the address of Bob. And then, so when we say Rob's pointer equals 20, we're actually telling Bob's pointer, which is pointing to the address of Bob, to be 20. So this is a perfect example of how to, if you understood that and you deducted that Rob was going to equal 10 and Bob equals 20, you understand pointers. If you didn't, I would highly recommend going to this link right here, and this link will be in the description. I will include that. And I would advise you to go to there and read all of the article and look at the Flash things that I showed you guys,